Hey everyone, welcome to The Explainer. Today, we're taking a really fascinating dual journey. First, we're going to get our hands dirty and figure out the beastly mechanics of refuse collection. You know, how these massive machines actually do what they do under the hood. And then, we're stepping right into the boardroom to unpack the highly strategic and honestly kind of complex business of international fleet sourcing. So we're literally going from the gritty, everyday reality of waste management straight into the global supply chain. Let's get into it.
But hey, before we talk business, look at this number right here, 3,000. These trucks, they aren't just giant metal boxes rolling down your street. They endure a massive 3,000 psi of hydraulic pressure every single day. I mean, think of a modern garbage truck as a mechanical beast, right? It's got this high-powered digestive system engineered to just consume and crush thousands of pounds of material without even breaking a sweat. It's wild.
Okay, let's dive into this. Here's our roadmap. We're covering the mechanics of waste collection, maximizing compaction, matching trucks to routes, chassis and superstructures, and finally, navigating international sourcing.
Starting off with Part 1, Mechanics of Waste Collection, focusing on the hydraulic workflow. So to really understand these municipal workhorses, we've got to look at the intense mechanical engineering powering them. And it all kicks off with the PTO. The power takeoff system. This is totally the unsung hero here. It transfers the truck's massive engine power straight into a specialized hydraulic pump, which fires up this brilliant four-step workflow. Step 1, power generation. The transmission engages that PTO, cranking out hydraulic pressures well over 2,500 psi. Step 2 is refuse loading. This highly pressurized fluid is literally the lifeblood of the truck. It drives these massive cylinders that actuate incredibly heavy steel sweep blades, scooping up all that raw trash. Then step 3, waste compaction. A sliding mechanism aggressively compresses everything against a super thick steel ejector panel. And finally, payload discharge. Once the truck hits the landfill, the tailgate lifts up and that exact same panel shoves tons of waste right out. Now, because pressurized fluid is doing literally all the heavy lifting here, keeping up with preventative maintenance on those hydraulic seals is absolutely crucial. Because if a seal blows, you lose pressure and the entire route comes to a very, very messy halt.
Moving on to Part 2. Maximizing compaction and payload efficiency.
To get the most out of every route, engineers meticulously calibrate the hydraulic valves to keep a steady, relentless counterpressure against that steel ejector panel. And this brings us to the compaction ratio, which is a critical performance metric telling us exactly how much raw, loose garbage can be heavily compressed into the back of the truck. So the crucial point here is that this isn't just a game of Tetris to fit more trash in a box. It's pure economics. A higher compaction ratio directly translates to fewer trips back and forth to the landfill, fewer hours burning fuel on the road, and just significantly lower operational costs overall.
And that brings us to this ratio right here. 6-to-1. No way, right? But it's true. This is what we typically see for high-density rear loaders, and it is an absolutely extreme level of compression. Just imagine taking 6 cubic yards of loose, bulky trash and literally squeezing it down into just one single cubic yard. It's kind of mind-boggling when you stop to think about it. And that magic trick is only possible thanks to those thick steel ejector panels and heavy-duty hydraulic cylinders that just absolutely refuse to buckle under all that pressure. All right, Part 3, matching trucks to routes and looking at fleet configurations.
Let's slow down the pace just a sec and pivot into fleet management strategy. You can have the most powerful hydraulic system on the planet, but if you're running an incompatible truck body on the wrong streets, you are severely limiting your daily urban collection efficiency. And this brilliantly illustrates that point. Look at the rear loader at the top. It's the gold standard for mixed residential waste. It needs a driver plus a loader or two, but it gives you that incredible 6-to-1 high-density compaction. Now, compare that to the automated side loader right below it. These are built for suburban curbside bins. They only need a driver, and while the compaction drops to about 4-to-1, the engineering here actively prioritizes rapid, continuous pickup speed over maximum payload density. Then you've got front loaders for those massive commercial dumpsters and roll-off trucks, which basically just hauls static bins of construction debris with zero compaction. The takeaway? Every single vehicle is a highly specialized tool built for a very specific environment. Next up, Part 4, chassis and superstructures, diving into the structural engineering.
Before you even think about mounting a compaction body, you've got to have a rock-solid structural foundation. In the world of global commercial sourcing, high-volume manufacturing heavily relies on standard commercial platforms built for severe dynamic loads. Brands like Dongfeng, Sinotruk, and Shackman, which can adapt to meet anything from Euro 3 all the way up to super strict Euro 6 emission standards, depending on your local laws. But what you put on top of that chassis is just as critical. Notice the difference here between standard mild steel and premium alloys like Q345 or NM450. Look, municipal waste is essentially a highly acidic, corrosive soup. If you build a garbage truck out of standard mild steel, that soup is going to eat right through it, and the truck will degrade and rust out incredibly fast. This is exactly why procurement teams absolutely must mandate high-tensile, wear-resistant steel alloys during the RFQ, or request for quotation stage. It extends the life cycle of the truck body by years and saves literally millions in replacement costs.
And drive types also heavily dictate municipal route accessibility and operational safety. A 4x2 configuration gives you a much-needed tight turning radius for navigating those narrow, congested city streets. But if your fleet is constantly battling rugged, unpaved terrain at a heavy landfill, you absolutely need a 6x4 or 8x4 setup, for sure. Also, leading manufacturers easily accommodate both left-hand and right-hand drive depending on where you are in the world, but buyers need to keep in mind that a right-hand drive modification usually tacks on an extra 2 weeks of factory lead time. You really have to tailor the chassis specifically to your local environment.
All right, bringing us to Part 5, navigating international sourcing, specifically procurement and quality control. Okay, so when you're buying municipal fleets internationally, there is a very deliberate, strict B2B workflow you have to follow to make sure you aren't buying a multi-million-dollar mistake. Validating the manufacturing process? Completely non-negotiable. First off, premium factories use automated robotic welding to ensure absolute structural seam integrity. Why? Because even a tiny pinhole leak of that highly corrosive waste fluid can destroy the underlying chassis over time. Then, those hydraulic cylinders we were talking about earlier, they undergo rigorous bench testing exceeding 3,000 psi before they are ever attached to a truck. This catches fatal seal failures before the equipment is even exported. Smart buyers also bring in independent third-party agencies like SGS or TUV to validate everything. And finally, specifying imported proportional valves during the RFQ might bump up your initial costs a bit, but it drastically minimizes long-term maintenance downtime once the truck is actually running routes locally.
Now, what's really interesting about this slide is the financial mechanics of getting these massive vehicles across the ocean. The minimum order quantity, or MOQ, is usually just 1 unit, which sounds awesome, but ocean transit isn't cheap. Buying in bulk, like ordering 3 to 5 units at a time, drastically reduces your per-unit shipping costs on what are called ro-ro, or roll-on/roll-off vessels. Standard lead times usually run about 30 to 45 business days. And as for payment, it's pretty standard commercial terms, a 30% advance via telegraphic transfer to initiate the chassis manufacturing, with the remaining balance firmly held back until after that successful third-party factory quality inspection we just talked about.
So, it really changes how you look at a simple garbage truck, doesn't it? Next time you hear that aggressive hydraulic roar outside your window on garbage day, I want you to consider the immense global supply chains, the robotic welding, and the extreme 3,000 psi engineering quietly at work right in your neighborhood. It really does leave you with a newfound respect for municipal sanitation, and honestly, it makes you wonder, what other mechanical beasts are silently keeping our cities running right under our noses? Keep observing, keep questioning, and we'll see you in the next explainer.